So now, before you use transformation of homogeneous, we have to know homogeneous function. We have to know homogeneous differential equation. So before you can even use this transformation of homogeneous function, the differential equation must be what? Homogeneous. And in our previous videos, we were able to prove that, or we were able to learn much under homogeneous differential equation and homogeneous function. So the next step here is that we'll try to solve questions under transformation of homogeneous. And for the form, original form of transformation of homogeneous function is your m of x, y, dx plus your n of x, y, dy is equal to 0. That's the original form. It's the same form as when we were doing homogeneous differential equation. You have your m of x, y, dx plus your n of x, y, dy is equal to 0. Likewise, if I want to rewrite this one well, I can just say that my I can just say that my dy dx is equal to negative m of x y over what? N x y. I just move this one to this side, divide both sides by this in order to get dy dx is equal to this one. So how to solve this one? We have several steps we have to follow. So first, we have to rewrite our given problem in terms of this form. So we'll say step 1. Rewrite the given problem in terms of the original form. So here, check the question. If the question is not rewrite, it's not like the question has been defined in these two terms. We have to rewrite this in this form. The second step here is that step 2. You will let a certain variable, let's say y is equal to vx, and this y is equal to vx is not always in the case that you have to always let y is equal to vx. There might be a certain question they will just define this term for you. So if maybe the question being given, they haven't defined anything for you, then you can let your y to be equal to what? Vx. So after letting your y to be equal to vx, we'll differentiate this y with respect to x because we have the dy dx. So I'll differentiate this y with respect to x. Then I'll have my dy dx is equal to. So here I'm applying products. We hold this one, differentiate this one, plus we hold this one, differentiate. So first, I'll hold v and differentiate x. I'll get what? V. Plus, I'll hold x, differentiate v. So I'll have dv equal what? Yes. So step 3. For step 3, I'll go back to the original question. Whenever I see y, I'll place y by out vx. Whenever I see dy dx, then I will place dy dx by this one. So here we just substitute y, let's say y and dy dx into the equation. And for the step 4, we will solve it using separation of variables approach. So after substituting your y is equal to vx and dy is equal to this one, the rest for you to do is you just see that what you have to do, you have to multiply terms and you need to get both sides. So that one you just see that it's just the same as the separation of variable. That's the first method we learned in our previous video. So now let's try to solve examples and let's see how the transformation of homogeneous function behaves. So now we have these 3 examples. Solve the following differential equation. We have a, b, and c. For the first thing, let's try the a. So a, we have x squared minus xy plus y squared dx minus xy dy is equal to what? 0. If you want to check whether this differential equation is homogeneous, we just go to know that this one is a homogeneous differential equation. This will be my m of xy. This will be my n of xy. The degree of this one will be definitely be 2 because we have x squared. Here too, we'll get something squared. We will get something squared. So from this case, even if this one is my m of x squared, the degree will be what? 2. Likewise, let's say this is my n of what? Xy. The degree of this side will be what? 2. Therefore, this one is what? Homogeneous differential equation. Then you can just, because it's homogeneous differential equation, you can just use the transformation of homogeneous to solve this one. And for you to solve this one, first step 1, we have to rewrite. So we want to rewrite this one in terms of what? Dy dx. So I will send this to this side. Then I'll have my x squared minus xy plus y squared. X is equal to xy dy. Making dy dx this side, then I'll get my dy dx is equal to my x squared minus xy plus y squared all over xy. That's I tried to make dy dx just a bit. Making dy dx this side, then I have to move this one to this side. Move this dx to this side in order to get dy dx is equal to this one. The next step here is that we let y is equal to what? Vx. Differentiate this y with respect to x. So my dy dx is equal to what? V plus x dv dx. Hold this one, differentiate this one, plus hold this one, differentiate this one. So now what I will do here is that, so this is my step 2. So this is my step 2. So step 3 says that substitute into the original form or into the equation. So here we'll substitute, then we'll have something like my dy dx here will change to what? V plus x dv dx. So I'll change that one to v plus x dv dx is equal to x squared. Whenever I see y, I will place that one by what? Vx. So I have x squared here minus xy. So minus x, my y here will change to what? Vx. Plus y squared, so here to be what? Vx all squared. All over x, y. My y here will go to Vx. So now rewriting this one, we'll have something like x squared minus x squared v plus x squared v squared all over my x squared v. So you see that in the numerator we have x squared, x squared, x squared. In the numerator we have x squared, so all the x squared will go out. So then I'll have v plus x v dx is equal to 1 minus v plus v squared all over v. Then I'll group it like this. I'll send this v to this side. Then I'll have something like 1 minus v plus v squared all over v minus what? V. This minus v taking the power x about 1. Then here too will be x dv dx. So now I have my x dv dx is equal to, so this one will be 1 minus v plus v squared minus v squared all about v. Here they also will be v, so just this 3 is v squared all over this v. Then this, we take this one, leaving 1 minus v all about v. So I have my x dv over dx. So what we'll do is we group like this, all the v's in one side and all the x in one side. Then I'll have v over 1 minus v dv is equal to 1 over x dx. I have the v, I have the x, and then we have to integrate this one. How to integrate this one is we'll get something like ln x plus a certain constant c. The problem is here. So what I will do here is I'll multiply this one through by negative. Then I'll have something like v over v minus 1 dv. So if I multiply the denominator by negative, I'll get the original question back. So I'll take v over v minus 1 and solve with this one. So this one is the same as v minus 1 square root of what? V. V into v is what? 1. 1 multiplied by this will get v minus 1. This will get 1. So my v over v minus 1 will change to what? One whole number. Here is what? Plus 1 over v minus 1. So anytime I see v over v minus 1, I will place it by 1 plus 1 over v minus 1. So here I have negative here integral. Now v over v minus 1 I change to 1 plus 1 over v minus 1 dv is equal to length x plus certain constant c. So now I'll integrate this one, but don't forget there is a negative here. When I integrate this one, I'll get v. When I integrate 1, I'll get v plus length v minus 1 all multiplied by what? Negative. So I have is equal to length x plus c. Multiplied by negative, I have negative v minus length v minus 1 is equal to length x plus what? C. Grouping all the lengths to one side, I have minus v minus c is equal to length x multiplied by v minus 1 that. So here I want to clear this one. So this one will be the same as minus v minus c is equal to x v minus 1. So the next step here is that I'll rewrite this one as e exponent negative v dot e exponent minus c is equal to x multiplied v minus 1. This I'll represent this one by a letter of what? A. Then I'll have a e exponent minus v is equal to x v minus 1. Right? Good. So here I'll have, if I want to make a the side, then I have to divide both sides by what? E exponent minus v. Then I'll have my a to be equal to x v minus 1 e exponent of v. But don't forget, we left something to be represented. Don't forget, you let y to be equal to what? Vx. So here, y is equal to vx. But you see that now I answer, we have something in terms of what? V. But the question was being asked in terms of what? X and y. Then I have to move everything from v to what? X and what? Y. So from here, I can see that v is the same as y over what? X. So I'll go back there. Whenever I see v, I'll place my y over x. Then I'll have a is equal to x y over x minus 1 e exponent y over what? X. So here I have a is equal to x. Here this one is over 1. So here just x, just 1 minus what? X all over x multiplied by e exponent y over what? X. This x will take this one. Therefore, my final answer will be a is equal to y minus x multiplied by e exponent y over x. So the second example, we have y minus x dy dx is equal to x plus y dy dx. So the first thing you have to know here is that you have something dy dx here, something dy dx here. So just remove all the dy dx out and just rewrite it in order to get dy dx equal to what? Something. So you have y minus x is equal to x plus y dy dx. Therefore, my dy dx will be equal to y minus x all over x plus what? Y. Move this one to this side. You get this one. So we have this one. So now we have fulfilled the first step of transformation of homogeneous. So the next step here is that step 2. I'll let y to be equal to vx. My dy dx will be equal to v plus x dv dx. So I'll go back to when we name this one equation 1. I'll go back to my equation 1. Whenever I see y, I will place the y by what? Vx. Whenever I see the y dx, I will place it by v plus x dv dx. So now this my dy dx will change to v plus x dv dx is equal to half y. So I have v x here minus x all over x plus what? Vx. X is common within both terms, so I'll factor all the x out and cancel it. Then I'll have v minus 1 all over 1 plus what? V. So I'll have v plus x dv dx. I'll move this v to this side, then I'll have my x dv dx is equal to v minus 1 all over 1 plus v minus what? V. This v2 is divided by what? 1. Then I'll have x dv dx is equal to v minus 1 minus v 1 plus x v plus 1 all about 1 plus what? V. Then working on the numerator, I'll have v minus 1 minus v all over 1 plus v. So I'll have x dv dx is equal to this, we take this one, so I'll have negative 1 negative v squared all over 1 plus v. So here I'll just do lighting. Look at the lighting, then I'll have 1 plus v dv all over 1 plus v squared is equal to 1 over x, is negative here, x. Then I'll integrate this side. So this one, I can even put the negative out. Now I have something like 1 plus v all over 1 plus v squared dv is equal to negative 1 over x dx. Good. So now but for this side, you see that we have 1 plus v all over 1 plus v squared. Then I can even split this one in terms of 1 over 1 plus v squared plus v over 1 plus v squared. So let's do that one and see. So I'll have make integral out 1 over 1 plus v squared plus v over 1 plus v squared dv is equal to negative 1 over x dx. So now what I'll do here is that I'll try to multiply to that. I'll try to split this one. Then I'll have 1 over 1 plus v squared dv plus integral of v over 1 plus v squared dv is equal to negative 1 over x dx. Right, so here, like I said, this one is the same as tan inverse of v. So this one will be tan inverse of v. So I have plus integral of v 1 plus v squared dv is equal to negative then x plus certain constant c. So how to solve this one? So for this side, I'll let a certain variable, let's say u, to be equal to v squared. So when I differentiate this u with respect to v, I'll get 2v dv. Then I'll have the u over 2 to be equal to v dv. So I'll have tan inverse of v plus integral of 1 over u du over 2 is equal to negative ln x plus c. So then we'll have tan inverse of v plus 1 over 2 out 1 over u du is equal to negative ln x plus what? C. So let me integrate this one. So when I integrate, I'll get ln u, but the u here is for v squared. So then I'll have tan inverse of v plus half ln v squared is equal to negative x plus c. Grouping all the length to one side, we'll have something like half ln v squared plus ln x is equal to negative tan inverse of v plus c. Simplify this one, but before I simplify, let me try to change all the v's. You know, from from the other side, you saw that whenever you see v, the same as y over x. So I have half ln y over x plus ln x is equal to negative tan inverse of y over x plus c. So this one is the same as ln y over x taking the power of half plus ln x is equal to negative tan inverse of y over x plus c. This one is the same as then x multiplied by y over x taken to the power of half is equal to negative term inverse of y over x plus c. We just end here. We conclude here. We'll take this one as our final answer. So in conclusion, the whole thing here is that the question will be given to you. Try to rewrite the whole question well. So after rewriting the whole question well, maybe you'll get the y dx equal to something. The next step here is that let your y to be equal to vx. If they haven't defined a term for you to use, you always let your y to be equal to vx. Differentiate your y with respect to x, the y dx, you get something. Now go back to the original question, the one we made it the y dx. Rewrite it to get your dy dx. Try to whenever you see y, try to fix that one. Replace it with what? Vx. Whenever you see dy dx, change the dy dx to what? V plus x divided x in order to get a certain format. Now try to rewrite or try to solve it using the idea of separation of variables. But don't forget the original question was being given in terms of what? Y and x. The dependent variable here there was what? Y. How's the independent variable there was what? X. So the original question was asked in terms of x and y. There wasn't anything like v. So after getting your final answer, check if there's a v there. Convert the whole v to what? That x and what? Y. Just simple as that. So expect my next video. Thank you.